Today on 5 Minutes with an RCDD podcast, we're going to talk about testing and how it's evolved from simple continuity testers to today's complex analyzers.
Don't hang up that phone. We've found what you're looking for. Welcome to the 5 Minutes with RCDD podcast. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you got to ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with terminating and testing parameters. What exactly does RCDD stand for? Really can't do diddly? Or just some guy that's just sitting around in a chair making podcasts. So join us as we talk about the ever-changing world of telecommunications, from ISP to OSP, from copper to fiber, design to installation. Now send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications. Here's your host, Chuck Bowser, RCDD.
So today on 5 Minutes with an RCD podcast, we're going to cover testers. Now, I have an expert online with me today, and I'm going to ask him what his first tester was in a second. But my first tester was it was a toner, and we would put it on continuity, and we'd use that along with a paper clip, and that's how we would test our cables. Testing has gotten just a little bit more involved since those days. So the guy I have on with me is Mike. He has over 40, Mike Bunning from Softing. He has over 40 years of experience in our industry, and it's not that often I come across somebody who has more experience than me. I'm at 38, so he has been a Bixby member for 25 years. He's been an RCDD since 1994, which means he got his about 3 years before me. He's worked as a technician, a project manager, an operations manager, senior management, design engineer, account representative, and he's currently the business development manager. He enjoys public speaking, so he was a glutton for punishment, evidently, and likes to conduct training. Welcome, Mike. Welcome to the show.
And I would say the likes to conduct training makes me more of a glutton for punishment than public speaking. Public speaking is an enjoyable task for me. Thanks for having me. Thanks for having me today, Chuck. My
pleasure. And I got to admit, when I was reading your bio that you sent over, for a second there, until I got to that last sentence, I thought I was reading my bio.
Yes, we do. We do have similar career paths and jobs. So
yeah, we do. We both do training now, but you do business development. I don't do business development. I'm solely training. That's all that I do. And if you'd have told me 10 years ago that I enjoy getting up in front of people I don't know and talking for 8 hours a day, I probably would have laughed at you. But it's kind of funny how life turns around. So I got to ask you before we get started. I already told you what my first tester was. What was your first tester?
A twin-axe tester. So I started in 1980 installing IBM System 34s, 36s, and 38s, and it ran on Bell 9207 cable. My God, I can still remember to this day. It basically was a little metal box that, had a battery in it, and when you got continuity, the lights lit. So it was a polarity-sensitive system. There were 2 wires, transmit and receive, and that was my first tester.
And you had to put the copper conductor on the side with the black dot.
It was a slotted connector, so it was keyed, so you had to line it up right. But my first real tester was probably a Pentascanner, which is getting into the the category days. So,
yeah, when it started, it did that.
Go have a cup of coffee after you hit test, because
exactly
45 seconds later that you got your test. So.
Yeah. We started off, like I said, I started off with we didn't have the fancy twin-axe tester. We tested with a paper clip and like I said, a 77M, a toner. And then from there, we went to the ModTap SLT3, which is just a little LED continuity thing. Is it would turn green if it was good, red if it was reversed. Do not plug that thing into something that's got active energy on it, because it will fry out your LED. Ask me how I know that one, right?
Yeah.
And then we went to the Pentascanner, and then which begs the question, since you are the testing expert, how has testing or certification become more challenging these days?
Well, I'm glad you asked that, Chuck. In fact, I brought a little prop here that I'm going to take my picture away, but I'll bring the little prop up over. We'll make it a little bigger here, a little smaller. So I'm going to focus on this area right here, and the pentascanners, and then the evolution into all the different brands of testers. A lot of people familiar with Fluke. They came out with the DSPs, the DSXs, and the Versa series. And Softing's had the WIreExpert 4500 since day one, and there's other ones. So we're gonna start with certification testing and how it's changed and evolved, and it has. Certification testing has gotten a lot more complicated. Back in the Cat 3, Cat 4 for the 15 minutes that it was around, Cat 5, Cat 6, Cat 6A, Cat 7, and now Cat 8. We only have to deal with two links, the permanent link and the channel. And for those of you who are nerdy like me and know the difference between these, basically permanent link, the way you remember that, that's what's permanently installed in the wall. So it goes from the patch panel to the outlet. Channel, you just simply add the patch cords. And we won't get into all the differences between them, but just trying to give you a feel for how things have evolved. We've got two more now. We have what's called end-to-end, and that is actually what's called an ISO standard. In the good old US of A, we pretty much go by the TIA standard. And that is used a lot in POE lighting, nurse call systems, and basically it's a segment-based test. So you can have multiple segments. And then MPTL is a very hot topic right now in terms of the new permanent links. It's where the technician will put an RJ45 directly on the end of the cable and then plug it into the device, be it a WAP, a wireless access point. It could be any IoT device that accepts that. So in terms of sophistication, now the technician has to be able to recognize, well, what kind of link am I doing? Okay. It has to have the right test reference cord for that link, has to have the right adapter on the end of the certification tool to test that link. And then they have to, most importantly, they have to select the right drop-down box from their tester to be able to accurately test that link. So that's kind of what's going on with certification in the copper world. And then in the fiber world, there's basically two types of certification in the fiber world. We'll make that a little bigger. So you have what's called Tier 1 certification, and that's typically done with the traditional certifier. And this product actually has a light source and a power meter in each one of these, and it's going to send a measured or referenced amount of light from the local over to the remote, take a measurement, compare it against the standard, and say, green check mark, you're good to go.
Keep it simple.
Keep it simple. Simple, but this is also in terms of cost. It's the most expensive of the tier of testers, or the different types of testers, and we'll talk about certification, qualification, verification later on. So this is a sole purpose device. It's going to give you one reading, 1 dB loss reading here, compare it against the standard and say good or bad. OTDRs are tier 2 certifiers. OTDR stands for optimal time domain refractometer. These are interesting in that you're using 2 fibers here. Here you're only testing down 1 fiber. And while there's a light source and a power meter in this guy, there's nothing attached to the other end. So the light just simply, if you're looking at a trace, it kind of bleeds off the end of the trace. So people will ask, well, if there's no power meter on the end of this, how are we determining what the dB loss is? And basically, these are sophisticated instruments. They look at reflection coming back due to impurities and anomalies in the cable, and interprets it and says, hey, based on what I saw coming back, this is what your dB loss reading is. So that's kind of what's going on with fiber certification. So that's kind of a quick overview of what's going on in the certification.
Let me take a step back to copper, right? So, because you're right, it's not just a matter of just getting out that paper clip anymore. Now, you got this. Let's be honest. The testers nowadays, they're expensive for when you look at it from a technician's perspective, right? They can range anywhere from
the owner's perspective. Trust me, they're expensive for them too.
Yeah, they can range anywhere from $9 to $25,000 depending on who you get and what bells and whistles. But to you look at it from a technician's point of view, right? They've got this tester, and there's like 3 different sets of heads, and they got to know which sets of heads they use, right? So you got the channel heads, the permanent link heads, and then the patch cord heads. Now, I know in the MPTL testing, I know that they just changed the standard recently where you're supposed to use the permanent link head and the patch cord head.
That's correct.
Can you explain the difference? Why
Sure.
they changed from the channel head to the permanent link head?
Let me grab my patch cord adapter here. So this is I'll get up close here. This is a patch cord adapter. So on a channel adapter, your test plane is going to end right there. So the thing you installed in the field, the thing you most likely messed up, was the thing you were not even testing. So the TIA stepped in and said, look, to test this properly, we're going to use a patch cord adapter because the test plane goes all the way to the back. So you test through that 45. So that's why they're requiring this. And this is also, by the way, category specific. So if you're doing 5E, you need a 5E patch cord adapter, 6A.
You anticipated my next question because, the MPTL is used for wireless access points, smart building stuff, and there might be Cat 5E cable, it might be Cat 6A cable. It could be a little bit of anything. Do you see any test differences between the traditional, ice cube mod plug versus the manufacturers now that have their field terminatable RJ45s? Is there a performance difference between those?
It all depends on how good the technician is, Chuck. So I would argue, having been a technician, and although I wouldn't even pretend that I could do it anymore because I can't see real well in TFC colors, but anybody who's worked with Category 6A cable, and as we all know, Category 6A, the twists inside are really, really tight. So just in terms of getting the pairs untwisted is one challenge because with a 45 clip, as you know, you got to lay them flat and they got to be in order. Okay. And plus the OD of a Cat 6 cable. I think the average OD is a
0.357.
Yeah.
Ask me, I don't know that.
Yeah. Trying to get that down underneath the crimping point can be a challenge.
Right.
So I would say on 5E, you're probably okay with a standard 45. 6 becomes a little more difficult. I wouldn't even want to attempt. Now, there are some manufacturers who make push through where you can take those 4 pair and kind of push it through the front end of the connector and cut it off. In fact, Leviton may make one. I'm not sure, but it's just a whole heck of a lot easier to put a field connected, designed MPTL connector on there.
So since you mentioned Leviton, I got to put in this disclaimer. This is not a Leviton show. This is only my opinion. I just happen to be an employee of Leviton. So anything you see or hear on this podcast is not of their opinion. It's Chuck and Mike's opinion. Just got to put that out there.
My disclaimer is I worked for a rep firm prior to getting this job that repped Bertec Leviton. And prior to coming to work for them, I ran the low voltage division of Glenwood Electric for about 8 years. And I was a premier Bertec Leviton installer there. So I'm obviously most familiar with their products. As you know, Chuck, there's a lot of the good products.
Oh, there are. There are absolutely some good products. So can you touch base on a little between, because I get asked quite often, what's the difference between certification and qualification and verification? I get that because isn't testing just testing?
Glad you asked that question. So again, going back to my little chart that I was looking at, a certification tool has one mission in life: to compare the selected standard that you have. And when you select that standard in a certification tool, be it 5E, 6, or 6A, there are different test parameters that are required to pass that test. Things like near end crosstalk, far end crosstalk, and there's basic things like wire map. Those are all loaded into the tester, and it is passively testing the electrical properties of that and then giving you the pass-fail. In qualification testing, with the new XG from WIreExpert, from Softing, and again, I'll talk to that one because, guys, I represent Softing. I'm familiar with it. There's actually a BERT tester in there, a bit error rate tester. So the difference between certification and qualification, we're actually sending real data over the cable with a qualification tester, and there are people who argue that that's a more real world test. And I have a favorite expression about the WIreExpert. About the XG. It doesn't care. What do I mean by that? With a certification tool, remember there's those test parameters that are loaded in, and one of which is distance. Okay, if you select you're doing a permanent link test, the standard says, thou shalt not go over 90 meters. And if you do, chances are you're going to fail that test. Well, we all know in the real world, because there are manufacturers who are making really good high quality cables, that it's perfectly capable of supporting 1 gig or 10 gig or whatever speed you're looking at in exceeding the distance. So what the XG will do, a qualification tester, is it'll send that BERT test over the cable. And again, it's an IEEE standard. It's required to send so many, I like to call them BERT bytes. It'll send so many bits of information, and it has to accurately receive all of that information on the remote side, or it won't pass the test. And it's a significant amount of data, by the way. And by the way, Softing doesn't determine the amount of data that needs to go through for a valid test. That's determined by the standard. In an example, for a 10 gig test, we're sending about 82 million bytes from one to the other to make sure that it's a valid test. So, and then there are what are called, as Chuck mentioned, we have certification, qualification, verification would be your basic troubleshooting tool. It's going to give you a wire map. It'll also, depending on whose it is, give you some other basic information, possibly signal noise ratio and delay skew. So just basic information. And those are kind of the real quick differences between the three, call it not grades, but styles of testers that are available today.
You know, one of the things I learned real early as an estimator when I got promoted to being an estimator is pay attention to the words, because words have specific meanings. So if you were an estimator or project manager and you're reading a scope of work and you see certification test or a qualification test, and if you didn't know the difference, you would just think, okay, it's just a regular test. Now, you mentioned the BERT test. How long does it take to do a BERT test?
Again, depending on what speed you're running at, because based on the speed, the IEEE says I have to send them so many bytes. It is a longer test. Your typical certification tools are running, depending on they're all around 10 seconds for a Cat 6A test. This could take 45 seconds to run that test. And I'll give you a real live example to the point you just made about reading. So I was doing I was helping out a contractor up on the East Coast, and they had tested I think it was about close to 100 fiber drops, okay? And they failed 3, okay? And barely. Yeah, they were this close to passing. And I happened to ask them, we took a look at how they had their tester set up, and one of the parameters you can set is, okay, what do you want to assign for a loss budget for your fiber optic connector? The standard says you get 0.75. They had set theirs to 0.5 because that was their company standard. They feel they're pretty good. And that's, by the way, where the new standard's going. And I asked the gentleman, I said, what did it read? What were you supposed to test to? And he looked it up and said, we were supposed to test to the TIA standard. He changed it back to the TIA standard, which moved his connector back to 0.75. Guess what? Those 3 runs passed.
Nice.
It was, just that 0.5 difference allowed him to pass those 3 tests.
Well, that actually brings up another question I just kind of thought of when you're talking about that is, the tester typically gives you either the green check or the pass, right?
Correct.
So every once in a while, technicians get this thing called a marginal pass, right? The star, pass, star, and stuff.
Right.
I know what that means. I mean, the test is within the accuracy limits of the tester, but can you be a little more specific as to what's going on in the tester when it gives you that star pass? What's a good way to resolve that problem?
You answered the question already. It's within the margin of accuracy within the tester. So how do you resolve it? Typically, you'll see that on when you have a very long run and you're close to it. One of the things, a little cheat method I did, if I were doing a Cat 5e install and I got a marginal pass, I'd simply put a Cat 6 to re-terminate with a Cat 6 jack. So I had little cheats that I would do to help get it pass. If again, you've got to read, Chuck, what they required. But,
right.
If you had a little extra in your service loop and that's what was causing it to be at that longer distance, you could try and tighten that up and shorten that up a little bit. So a couple of things you can do, but you can't change the accuracy of the tester.
And just to clarify for somebody who might be listening, and I know Mike knows this, and I know this, I know probably a lot of people know this. He said about putting a Cat 6 connector on a Cat 5e. it's okay to put a better performing connector on a cable. That they will not harm the performance. If anything, it'll make it perform a little better. But you never want to go backwards. So if you have a Cat 6 cable, you don't want to put a 5E connector on, because that will definitely affect its performance and make your test even go worse. As a general rule, I tell people, it's a couple step process. If you get that marginal fail, it's most likely the simplest thing, termination. Go back and re-terminate both sides. And if that doesn't resolve the issue, then look at your length. And again, like you said, look at see if there's any excessive loops or anything up in the ceiling, stuff like that might cause you some problems. Let's switch over to fiber, right? So now there's the one jumper reference method and the two jumper reference method, and I know what my company accepts and what it doesn't accept. And when I say that in classes, I usually get pushback from students because they say, well, the other tester is a better tester. Why don't you accept that one? You know where I'm going with this, don't you? So what is the difference between tier 1 testing and tier 2 testing?
Okay. And we can kind of go back to my poster here, and we'll make that big. So again, tier 1 certification and tier 2 certification in the fiber world. There's nothing wrong with either of these. They're different tests. Okay. For warranty work, they're typically wanting a tier 1 certification. And the reason being, there's a light source and a power meter in here, and a light source and a power meter in here. You're getting a extremely accurate dB loss reading because you've got a power meter here. So you're putting the reference amount of light in here, and you're seeing how much makes it to the other end. And obviously, because it's a certification tool, it then turns around and compares it against the standard you selected. With the OTDR, there's no power meter on the end. You're basically shining a very high-powered laser in the beginning. And again, the reason it has to be so strong is because our particular one, I think, has 160-mile range. And that's why you use launch cords. The launch cord is, in essence, attenuating or dampening down the signal, if you will. So it's not blazing hot when it hits that first connector, so it doesn't blind it. But there's no power meter here. So this is an interpretation of what the dB loss is. It's very accurate, don't get me wrong, but it's not as accurate as this. So that is the difference between tier 1 and tier 2 in the fiber world.
Yeah, I've always viewed tier 2 testing as a good troubleshooting tool.
Oh,
and tier 1
favorite.
testing.
It's my favorite troubleshooting tool because this device, this tier 1 certification here, you're only getting one number being how much fiber did I lose from this end to this end. You could have gone through 5 manholes, patched through an IDF, and it's not going to show you any of those events. It's simply going to say, based on going through all this stuff, here's what your reading was. This device will show you every event along the way and give you the dB loss on each of those events. Not only dB loss, this will do what's called OLR too. It gives you the reflectance back. So this is a great troubleshooting tool, very accurate, but this is what they want for warranty work and for doing certification.
Right.
And again,
now, another issue arises quite often with fiber testing, and I got to admit, I was one of these until somebody mentored me and taught me, is the difference between one jumper reference and two jumper reference. Because I was doing two jumper reference for probably 3 or 4 years, thinking it was a one jumper reference, till somebody finally sat me down and said, no, what you're doing is a two jumper reference method. What's the difference between those two, and why is that important for the cable's performance?
Okay. And I'll kind of echo along with what you just said. I teach fiber class every Thursday. I travel around speaking on it without doubt. The one jumper, two jumper, three jumper is the thing that causes people the most heartburn. It's not difficult. You just have to kind of understand what's going on in the tester. And let me do a little not a disclaimer, but something that'll make everyone's life easier. Whether it's one jumper, two jumper, three jumper, Chuck, I know you're going to agree with me here. If you don't own a fiber optic inspection scope of some type, you're just asking yourself for pain, because it's just so much. It's all. I couldn't even imagine testing without a scope. So The standard has recently changed. It used to be 2-jumper was acceptable. All of us guys who are, and even some of the younger guys, we loved that because it was simple. Okay, you would connect your 4 leads. You had transmit and receive on one of your certifiers, transmit and receive on the other side. You coupled them together and hit your set reference. It zeroed out all 4 of those cables all at once and set the reference between them, and you were ready to unplug and start testing. Well, what they determined was when they weren't really testing that receive cable, it was being zeroed out during the reference process, that it wasn't quite as accurate as the 1-jumper set method, which is now recommended. So what you do with the 1-jumper reference is basically you set a reference, transmit the receive, transmit the receive. You're only using 2 reference cords, and then you're going to basically remove the receive cable, plug it into the coupler, and then introduce the receive cable at that point. So at that point, it looks exactly like the 2-jumper. But what you're going to do is you're going to run an auto test on that, and the standard says when you've introduced that receive cable, it has to be extreme low loss. You don't want any dB at all. And it's logical. You just want to make sure that your reference cords and your tester aren't adding any loss to the cable under test. You only want to measure the loss of the cable under test. And to give you an idea of how tough that test is, the standard says when you've tested those receive cables that you added, if it's multi-mode, you need to be less than 0.2 dB. And if it's single mode, and if it's multi-mode, it's got to be less than 0.15. So it's a very, very stringent test. That's why nobody likes it. If you got anything that's dirty, it's tough. One of the things I've done for our training classes is I created 1-pagers, little cheat sheets on how you do the process. But again, getting back to something you said earlier, Chuck, know what your requirements are. Okay. Some people, they're not asking for TIA certification on their fiber. By all means, do a 2-jumper set reference, get out of Dodge, make life easy.
Right.
And the other thing that comes up in my class a lot is, what's the difference between single directional and bidirectional? So if I bring this diagram back here, and by the way, both are acceptable for a certified report. So a single directional test, you're basically going to send your measured amount of light to here and take a reading. You're done. Bidirectional, you're going to send it. You're going to flip the transmit and receive and send it back the other way. So basically, you're testing it in both directions. And Chuck, you'll get no argument from me that a bidirectional test is a more thorough test.
Right.
But again, I had a mantra. I ingrained it in my technician. What are you contractually obligated to test to? And the translation of that for a contractor is, what am I getting paid to do? Because single directional is much quicker than bidirectional.
Well, and as an estimator, right, when you build up the labor budget, it's based on the time value to do a single mode test, a single directional test, which is less time. So you're actually using time on the job that wasn't estimated in the job.
Oh yeah, and you got 500 drops. That adds up.
Absolutely.
While the set reference isn't as much as a time thing, but you can set a 2-jumper reference a whole lot quicker than you can do a 1-jumper set reference. Yeah.
Hey, how long does it take the softing tester for the power source to stabilize before you calibrate it?
I recommend 15 minutes that you let it set up and stabilize. It probably can do it quicker than that. Has a lot of other factors in play, humidity, temperature, that kind of thing. So, but yeah, it's good. It's a good idea to let them warm up.
Especially if you're bringing the tester out of a cold truck into an 80-degree building, right? It needs time to recoup from that change.
I wouldn't leave the tester sit out in a cold truck because there's nickel cad batteries in there and they don't like those cold.
I'm not recommending that they do, but I know what technicians do though, right? Yeah. So yeah, absolutely. Good practice is bring that tester in, and even at home, bring it in and keep it nice and warm and stuff. Yeah. When you talk about, we're talking about fiber budgets here in a second, but the budgets actually change whether you're using test reference cords or standard cords, right? Give us a brief synopsis. What's the difference between a test reference cord and a standard cord?
Okay. When you are setting reference, you should never use standard patch cords. So don't think you can go down to your local distributor and just order a patch cord and get away with that. the test reference cords that we put in our kits and most of the major testers put in, they're not your father's Oldsmobile. They are extreme low loss connectors. So your typical connector today, and I would argue that most people are probably doing some sort of camming process or fusion on. When they buy that connector from their manufacturer or their distributor, it's coming pre-polished at the factory in a nice clean environment at 0.2 dB or less. Okay. Extreme low loss connectors that are on test reference cords can be as low as 0.02. Again, the whole idea is they're not adding any loss to the cable under test. Another big difference in the multi-mode world is our test reference cords are what are called modally transparent. That allows our multi-mode adapter to test OM 1, 2, 3, 4, and 5 without changing test reference cords, unless, of course, you ST, SC, LC. So that allows you to use one adapter to test all the different OMs. Encircled Flux isn't an issue with single mode because the core size is so small.
Right.
So,
very cool.
Is it? And I get lots of questions on that. And I can talk on Encircled Flux a little bit if you want.
Let's hit that because that's something that we don't really teach in our class. It's a little bit more depth than we have time for. So yeah, give us a quick synopsis on.
Well, it is going to be quick and it is going to be non-technical because, as you know, I'm not an engineer. I'm a sales guy. But Encircled Flux has been a problem with multi-mode cables since day one. You got a big core, 50 micron, 62.5. You shine the light in and it'll bounce down a path. You shine the light in 2 seconds later, it may take a different path. And typically where it's taking different paths is out on the edge, called the higher orders. Okay? So they've been trying to fix it forever. 70-30 launch cords. The latest thing they had was a mandrel. I wish I had one. 1-inch diameter piece of plastic, and you wrap the test reference cord around.
And they charge you a buku money for that.
Yeah. The problem was some technicians would do 5, some would do 8, some would use their Bic pen, some would use their thumb, some would use a moment of silence. So you were never getting repeatable results. TIA stepped in and said, look, we're going to define where the light needs to go when it comes out of the laser. And that's all it really is a defined launch. So that's why you'll see FC, Frank Charlie, connectors on test equipment, because that FC has a slot, it's a keyway, and it's threaded. So when you line that up into the top of the tester, you're getting perfect alignment. So that very precise launch is going exactly where it needs to go into the test reference cord. So Softing built that in right into their adapters. So it's kind of nice. All right.
So the fiber, but you mentioned it's changing because for years we were teaching 0.75, 0.75, 0.75. And you mentioned some of the newer numbers. Why is the new fiber budgets changing?
Okay. Well, when I took my RCD in 1994, that same fiber budget formula is still current today. 1994. Cable construction has gotten better. Okay. And connector technology certainly got better. So 0.75 back in the day when you and I were puck and polishing and hot melting and doing that kind of stuff, 0.75 was probably admirable. But now, as I mentioned, the camming products and the fusion-on products, they come pre-polished at 0.2. 0.2 is nowhere near 0.75, so it's overly generous.
Right.
Same thing goes with the splice budget. Back in the day, we had a little camming product. It was mechanical, and we tweaked these ends with the fibers in between. The budget for that is 0.3. Most people fusion splice. Sometimes it won't even show up.
Right, 0.00, 0.01. Yeah.
So that's in the process or has changed. And as soon as it's published, like in Softings, it'll be a firmware upgrade and the new formula will appear. So, that's, we're getting away with it should be pretty easy to pass these days with that kind of budget loss.
Oh, absolutely. So so it's a challenge to stay current. And so one new acronym that I see quite often, and I didn't actually know this was until you and I had our Zoom call, a month or two ago, and that's DCRU testing. Yep.
DC resistance unbalanced. So it's coming into play with because of the higher wattages that are being done in POE with the new POE++ approaching 100 watts. They are very concerned with heat buildup, particularly in bundles of cable, particularly in bundles of existing cables that they're starting to apply higher and higher wattages to, and basically that measurement, the heat buildup occurs because of resistance, right?
Right.
So they're starting to measure that more closely now. It's currently not in a requirement in the standard, but it's something that's important, and I think you'll see more and more people being concerned with that as people start deploying more and more of the level 4, the 100-watt POE. So
actually, the last episode I just did was actually on fire stopping for National Fire Prevention Week, and one of the things I touched base on there is what's called the auto ignition point of materials. Auto ignition point, in layman's terms, basically means you raise the temperature of the environment to the point where that material spontaneously catches on fire. Every material has an auto ignition point. And when you put energy down a low voltage cable, when it's just a telephone signal or just a regular network signal, there's very minimal rise. But when you start talking about 100 watts of power and you start putting that in a bundle with other cables with 100 watts of power, especially with all of the smart building cabling, this is something that we as an industry really need to keep an eye on. That's why I was kind of glad to see that there's at least now some kind of test for that. Something else that's new is this whole MICE stuff, right? That's mechanical ingress. I can't even remember what the acronym means. I should have had it written down so I could look like I know everything, but hey, this show's real. So what is MICE and how's it come to as far as testing?
MICE is something that's probably more prevalent in the industrial world. So there are disruptors or sources of I don't want to say just EMI, but that probably covers most of it. So there's interference that is inherent in all applications locations. And what MICE does is it tries to put a category to the environment based on the amount of noise, electromagnetic interference that's occurring in a given area. An example, a office area might be a level 1. Okay,
right.
You get out into the industrial floor and they have multiple ratings for it.
Right.
What's interesting though is your certification tool probably isn't going to tell you that. The reason being, while certification will measure signal to noise ratio, so in other words, you have something, an induction motor, a TIG welder that's creating that, it has to be happening in the exact instant that you've run that test. So it's not really a very good tool for that. A better tool would be our qualifier, because we have the ability to run a BERT test over a longer period of time, and we can report on it. So you can look at your time and see where things are occurring, and you notice, oh, yeah, that variable frequency drive kicked on at 4, 6, and 8. Oh, look at the spikes at 4, 6, and 8. So a qualification tool, I think, is probably a better tester when you think you might have some sort of interference going on the cable.
And you could actually even have a cable that might even run through multiple environments. This kind of made me think of an issue I had once when I was a young technician. We did some cabling at a law firm in Washington, D.C., and I think I told you this when we were on Zoom. And so the secretary called us up and called the IT bar and said the cable wasn't working. So they came out and they looked at what was working. So they said it has to be a cable problem, right? So they called us out to come fix the problem. We go out there with our very expensive tester. We put it on and we test it. Comes back, passes with flying colors. It must be an IT problem, not us. So that's about 3 gyrations of this going back and forth. Finally, the IT staff said, "Look, no more of this. You guys be out here on Monday at 8 a.m. We'll be out there Monday at 8 a.m. There's no more of this passing the buck." So we get there and, the lady's working on our computer, working fine. I test the cable, it's working fine. And the IT guy looks at it and goes, everything's fine. So we're sitting, we're just kind of talking. We changed something. We're talking about an upcoming project. And all of a sudden the lady goes, "Hey, my computer quit working." And we looked at it real quickly and sure enough, it lost connectivity. And I realized that just when she'd said that, right behind her desk was a HVAC room, mechanical room. And the cable would run through the mechanical room, and the installers had ran it through the springs. The springs help dampen the vibration so you don't feel it, right? And so every time that thing would kick on, it would short out the cable, and when it turned off, it would work. And you will never catch that unless you're exactly at the moment it's causing you those issues. So,
yeah.
So, testers come in a lot of different kinds of varieties. And, I know you have some competitors out there and stuff, but I think one of the interesting things is your testers have 2 screens. Other ones don't. Yep. And so what advantage does that give to a technician when they're out in the field? Why do they care if they have 2 screens? Because the other guy is just that's the guy who was flipping burgers a couple of weeks ago. Why does he need a screen?
Yep. Well, typically, and I was guilty of this, when I would send my testing crews out, I'd put my skilled technician on the local side, and probably one of my least skilled, least expensive technicians on the remote side. Because typically, before you had that dual touchscreen capability, the only thing the guy on the remote side was doing was looking for the green light. On to the next screen. He never really learned or was part of the process. So by having a full touchscreen remote, you've added intelligence to the remote side. You've made the guy on the remote side probably a better technician. And there are other things when doing the setup where you can see. Let's pretend for some reason that the more skilled guy set the tester to the wrong test setting, and the guy who's on the remote side said, "Wait a minute, this is a Cat 6 cable. Why is this thing set up to 5E?" So being able to view that is nice. And when I can tell you, when you are doing service work by yourself, it's invaluable, because if you've ever had to plug it on the MDF, walk 200 feet to the IDF, walk 200 feet to the telecommunication outlet, hit the test button and see it failed and not know why, and have to walk back 200 feet to the MDF and see, and then only to learn that it's on the remote side and walk back.
All the way back.
So having that full touchscreen is just very nice. And also something we do is I'll show a picture of it. Since we have a full touchscreen in our digital inspection scope that we have, guess what? Because I have a screen here, I can look at pictures. Yeah, so I can look at pictures on this one and on the remote.
That's slick.
Yeah,
I like that.
That gives you some nice testing capability. So,
yeah, when it comes to fiber, cleanliness is next to godliness. It's your most common problem is contamination. Is your most common problem. And it's funny because you mentioned about the tester being set up incorrectly, and I just got asked to look at some test results by a friend of mine who was having issues. He said, "Well, Chuck, it's not passing. It's shielded cable, and there's like these 5 cables that won't pass." And I said, "Well, shoot me the test results, and I'll look at them and stuff." And then I said, "Well," and I said in that same email, I said, "Did you make sure you had the tester set up correctly?" And he responded back almost like insulted. "Well, of course, I've been doing this for 20 years. Of course I set it up correctly." And he sent it to me, and guess what the issue was?
He didn't have the shield turned on.
Nope.
Yeah. Yep.
Again, sometimes just keep it simple. Yeah, it really, really is. So let me have one final question before we sign off, because what do you see as the biggest challenge moving forward for someone as far as testing in this industry?
Biggest challenge. Wow. Good question. You're not stumping me here, but
there's so much to pull from. I know. I understand.
I think the biggest challenge in terms of testing is knowing where to find the appropriate knowledge to be able to operate, be it my tester or one of my competitors' testers. So that's why at Softing, training is such an important issue, and we provide training to our end user customers at no charge. And I can't speak to what some of the other tester manufacturers do, but that is the biggest challenge. And it's no secret, it's the use it or lose it mentality. Right. Unfortunately, sometimes technicians will test, put it in the box and not show up, not do anything for 6 weeks later. Testing is like anything else. If you practice and become proficient at it, right, it'll become second nature to you. So.
And that's one of the things I love about your company is because you always were good about providing the training for free.
Happy customers, man.
Oh yeah. You have competitors out there, and people probably knew who they are. They're kind of like the IBM of the testing world. They charge for their testing, and there's anything wrong with that, because as a business, you got to recoup your costs. But from a company standpoint or a technician standpoint, that's a barrier to entry. And that's what I said. That's one of the biggest things that holds technicians back is they're hungry for information. They want to learn, but they're not going to want to go out and spend $300, $400, or talk their boss into spending $400 to get training.
Yep. Because as much as that $400, typically, again, I being an operations manager, the $400 wasn't so bad. Sometimes it's, hey, he's out of the field for 8 hours. So not only am I paying him to be there, not only did I pay the $300, but I didn't get to build 8 hours of his time. Right. So we understand that. That's why we do, it's primarily Zoom-based training. If you happen to be near where I live, I'll be happy to come out and do it. But yeah, it's very effective, the Zoom-based. And we do it on a regularly scheduled basis. And
that's a big difference between somebody in the field and somebody in the office, like a project manager or an operations manager, because it's always cost impact. Because the technician just thinks, well, it only costs $400, and you hit the nail right on the head. Well, yeah, it costs $400, and then we got to pay your hours while you're there, and we lose the revenue while you're there. And if you're doing like when I teach classes, quite often my average right now is about 4 people per company. So they're taking 4 people out of the field and putting them in the class and losing that revenue. And so that's one people don't think of. So I appreciate your time today, Mike. It's a pleasure having you on.
I thank you for having me.
My pleasure.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.